Today, I'm going to solve the question number of bit changes to make two integers equal. So here we are given two numbers, the positive numbers that is n and k. So you can choose any bit in the binary representation of n that is equal to 1 and change it to 0. Okay, and we have to return the number of changes needed to make n equal to k. If it is possible, it is okay. If it is impossible, then return minus 1. Okay, let's check the example. So here we can see n is equal to 13 and k is equal to 4. So if we represent it in binary form, then 13 will look like 0 1 1 0 1, and 4 will look like 1 0 0. Okay, so here what we are asked is we can change any bit which is 1 to 0 of n. Okay, so we'll only look into n. We can change any bit of it which is 1 to 0 to make with equal with this k. So here we can see, so if I add 0 here in front of, okay, 1, so it will be the same, right? So here we can see we need to make this two ones to 0. So now if I change this one to 0 and this one to 0, then we can see both are equal. So we have to return the output as 2. Okay. Next is 21 and 21. As both the numbers are same, there is no need to change any bit, so the output is automatically 0. Then example 3 is 14 and 13. Okay, this if we make, okay, this is 13 only. Now 14. So 13 was 1101 and 14 will be 1110. So if we see, there's 1 0 and here 1, we cannot change 0 to 1. We can only change 1 to 0 as given in the question. So it is impossible to make this both as equal. Okay, so that is why it is returning minus 1. So let's start coding. So okay, let's keep it the same. So what will be our first condition? Our first condition will be if the both numbers, that is n and k, equal, then we have to return as 0. So if n equal to k, then we will return 0. So we'll need 0 number of changes which needed to make n equal to k. So what next we have to do is, first I'll take one variable as a count, which will be 0 initially. Then I'll use while loop. Okay, what will be the conditions? As it is in the binary form, we will check in the binary form. So what will I do is I will check this one, this 0. So if 1 and 0 is there, then we can change it, right? So that is why I will increment count. We don't have to actually change it. We What we have to return is we have to return number of changes which are needed. They didn't ask us that we have to return the changed or anything. Okay, so that's why I will only count. So if I got 0 and 1, then it is straightforward that it is impossible to make this both numbers as the same, because we cannot change 0 to 1. If 1 to 0 is there, then we will increase the count, and if 0 to 1 is there, then we will directly return as a minus 1. That is, yes, it is impossible. So what will be in the while loop? The condition will be n is not equal to 0 and k is not equal to 0. Okay, so first we'll take if, okay, instead if x, take x equal to n percent 2. That means we are taking the last this binary digit. Okay, and int y is equal to k percent 2. So we are taking this last digit. Okay, and if n, no, not n, if x, okay, if x is equal to 1 and y equal to 0, that means we can change it. So I'll increment the count. Else else if x equal to 0 and y equal to 1, that means it is impossible to convert this 0 to 1, right, and make them both equal. So we'll directly return minus 1. And the last condition will be both are equal, so we no need to check or okay. So now n is equal to n divided by 2, and n x sorry k equal to k divided by 2, or you can use the shifts also. Okay, so this is our condition. Okay, so this is our first condition. But what if this while condition, when it stops, when n is n becomes 0 or k becomes 0, because we have added and, right? If both the conditions are satisfying, then only it enters into this loop. If any of this doesn't satisfy, that is n equal to 0 or k is equal to 0, it will be out of that loop. So what if n is not equal to 0? That means here it can be, okay, so let's take this number and this number. So here if we check, okay, these four numbers, and okay, I'll add this. So 1 and 0, then increment the count, then 1 and 1, same, same, same. Now these three are remaining. Okay. So to make this equal, what we have to do? We have to convert this ones to 0, right? So what we have to do is we have to again add one while loop while n is not equal to 0. Okay, take one variable, or no need to take variable. If n percent 2 is equal to 1, then we can convert it to 0. If it is 0, then no need to convert it to again 0, right? Because it will consider here 0 0 0 only, right? Okay, then we have to increment the count, and n equal to n by 2. Okay, so this is the next condition. Again, what if k is equal to 0? What happens in that case? Okay, so if, okay, some, so if the number is like this, okay, okay, so what does it mean? Can we convert this 0 to 1? Can we change this 0 to 1? No, right? So directly we can say, if k is equal to 0, okay, sorry, k is not equal to 0, okay, k is not equal to 0. So here after checking these two numbers, n becomes 0, then we'll get out of this loop. Then k, if k is not 0, then directly we can say return minus 1, because we cannot change 0 to 1 or any number. Okay, then lastly return our count. Let's check by running it. Yeah, we can see accepted. Then let's submit it. Yeah, so our solution is accepted. So this was the simple approach which we can use to solve this question. Thank you.